Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in Unit 4. We're going to see register transfer and ALU operation. So far what we have seen is we are seeing fundamental concepts of processor, how processor performs various operations, right? And today we are going to see how the processor transfers from one register to another register and how it performs, how it executes the ALU operation. That is what we are going to see, right? And before going in depth about the register transfer, this is the basic diagram where you have to understand, right? So first thing is you would have come across this particular instruction, right? That is moving one register, for example, from R1 and R4, right? You would have come across this particular instruction, right? That is, we have to move the content from R1 to R4, right? And so far what we know this, that is, we just know this instruction, and once this instruction is executed, the information which is present in R1 will be transferred to R4. That is what we know, right? But how the processor transfers this information, that is what we are going to see here, right? So for that you have to understand, we already know that internal bus organization, right? We have in the previous video we have very clearly explained about the internal bus organization about the processor, okay, right? And in that you would have understood that all the registers, ALU, temporary register, everything is connected to this internal bus, right? And this registers, every register will have two control signals. You have to understand very carefully. You will have two control signals. Every register will have two control signals. One is RI in and RI out. RI is nothing but it can be 1, 2, 3, R1, R2, R3, any registers, right? It will have two control signals. One is input, another one is output. Okay, right? You can see here, right? That is, this is the this is a switch, right? By using the switch, it is connected to the internal bus. This register is connected to this internal bus through the switch. Okay, but this switch is controlled by these two control signals, which is RN and R out. Okay, right? You got to understand very clearly. If Rn is set to 1, if Rn is set to 1, right? What will happen is the content in the internal bus, will be placed in this register, right? From internal bus, whatever information which is present in internal bus, it will be sent to this particular register if this is set to 1, if this is enabled, okay? And similarly, if this is enabled, right? If RI out is enabled, the content which is in the register, you have to understand very clearly, this is input and this is output, okay, right? And what the content, if this is enabled, if RI out is equal to 1, right, what will happen? The content in the register in this RI will be sent to the internal bus, okay? So if RI in is equal to 1, from internal bus the data will be sent to the register, and if RI out is equal to 1, the content in the register will be sent to the internal bus, right? This is more than enough to understand the register transfer information, okay, right? And you got to be very clear, right? And at one clock cycle, at one time period, right, only one register output will be enabled, right? So that the content will be moved to that particular register at one clock cycle, okay, right? So far clear? Okay, and now you got to understand like this, like say for example, I take this example, move the content from R1 to R4, right? If R1, R4, that is, in this instruction is nothing but we have to move the content from R1 to R4, which means there is already a content present in the R1, right? Content is present in the R1, that content has to be moved to the R4, right? How it can be done, right? That is, we have to enable R1 out, correct? R1 out, correct? R1 out. For example, if this is R1, what you have to do? We have to enable this one, right? If this is 1, R1 out is enabled, what will happen? Right? The content in the register will be transferred to the internal bus, correct? The content will be transferred to the internal bus, right? And then now the information is sent to the internal bus, okay? Now what happens here? Now it has to be sent to R4, correct? R4. So consider like here is R4. Here is R4. Just for an example, right? Now what we have to do? We have to enable R4 in, correct? R4 in, that is R4 in must be 1. It has to be enabled. That is input of this must be enabled, right? Input has to be enabled, right? If this is enabled, what will happen? Now the information which is in the bus will be transferred to this particular R4, right? So what happened here? The information which is in R1 is transferred to internal bus and then it is transferred to R4. This is the normal register transfer information. This is how the content of the register is moved from one particular register to the other register. Clear? Clear with this? Okay? Right. Now each and every register, right? I said about clock cycle, right? So every operation, every transfer will be happening in a time period, right? The processor clock will have a specific time period, right? A clock signal, right? A clock signal will be there, right? So at every clock cycle, like one particular operation, any particular operation will happen within the time period. There will be a specific time period. It can be one clock cycle or it can be more than one clock cycle, right? Moreover, processor will perform all the operation within one clock cycle. It performs all the data transfer, right, within one clock cycle. So far clear, right? Now you have to understand how the data, you can see here the content of this particular data R1 is moved to the internal bus. Okay. Now here from this internal bus, how the data is loaded in R4, how it is loaded, right? That is, the registers will have a flip-flops, right? So the implementation of register, you can see here, this is the register implementation. Okay. So this is the register implementation, right? And every register implementation, that is every data transfer will take place. Before coming to this, you have to understand every data transfer will start at the start of the clock cycle, right? At the start of the clock cycle, whenever there is a rise in the clock cycle, right? That is, if you take this is a clock cycle, this is the rising edge and this is the falling edge, right? Whenever there is a rising edge in the clock cycle, the data transfer will happen. Okay. Right. Now in this instruction, R1 and R4 will be set to 1, correct? Will be set to 1, right? Only then the content will be moved from here to here, right? Right. So once it is enabled, what will happen is this R4 will have a edge triggered flip-flop. Every register will have a flip-flop, right? And whenever there is a change, whenever there is a rising edge in the clock, what this flip-flop will do is, it will load the content which is here in the input. The data will be loaded in this particular register, right? For every clock cycle, right? That is, if there is a data, it will be loaded. Okay. That is, any data transfer will happen at the start of the clock cycle. That is how you have to understand. Okay. Right. And what is the implementation? You can see here, whatever said right now, how it is connected with this particular bus, everything you can understand here. This is the implementation of the register, right? As I said, every register will have a flip-flop. Okay, you can see here, this is an edge triggered flip-flop. It is a D flip-flop. Okay, and the clock signal is present here, right? And it has a multiplexer. This is multiplexer, right? And this is the internal bus. Okay, you can see here the multiplexer will select either 1 or 0, right? If Rn is equal to 1, if Rn is equal to 1, what it will do is, it will connect the output of this bus. You can see here, this bus, if R1 is equal to 1, what it will do is, it will connect the bus, right? The bus will be connected, the bus output will be connected to this flip-flop, right? The bus input will be given to the flip-flop, right? And if it is 0, if Rn is equal to 0, right? If it is 0, what it will do is, it will just give the feedback of the previous data, right? The previous value which is present in the flip-flop, it will be given as a feedback. Okay, you understand now? If it is 1, it will connect to the bus. If it is 0, it will not connect to the bus. It will use the previous value. Okay, right. So this is the operation of the register, and you have to understand the flip-flop, right? This Q, it can be connected to the bus using this particular switch, tri-state gate. This can be called as a tri-state gate. Tri-state gate. Okay. So only if it is enabled, what it will do is, it will connect to the bus. If it is not enabled, it will not be connected with the bus. Depending upon the value of Q, either 0 or 1, right, it will connect to the bus or it will not connect to the bus. Correct? You understand the implementation? Right. So far what we have seen is we have seen the data transfer information, how the data is transferred from one register to the other register. Clear? Right. So whatever information which I said right now, you can see here, right, I have said the same instruction, right. R1 has to be set to 1, R out set to 1, what will happen? It will load into the RI, right. And if it is R out is set to 1, the content will be placed, the content of the register will be placed on the bus, right. And similarly, as I said, only one bus, that is only one RI out will be set to 1 at a time, right. Other time it will be set to 0 because only one bus has to be, only one register output has to be enabled for the one clock cycle, so that the content will be transferred to that particular register. Okay, right. And as I said, you'll have processor clock, right, and you have time period for each and every operation, right. That is what we have seen so far. And I have said about edge triggered pulses, edge triggered flip flop, right. And what is multi-phase clocking is nothing but, as I said, there is an edge triggered flip flop. What is edge triggered flip flop? Right, as I said, every change at the start of the clock cycle, it will change the state, correct? And it will load the content, right, as I said, right? The content from the R4 is moved, that is loaded into the register, right? And there are flip flops which will change the state, which will do data transfer at both the edges, that is at the rising edge and as well as the falling edge, at both the edges. There are different techniques, okay? And if there is not a trigger pulse, there is not a trigger flip flop, if it is not an edge triggered flip flop, it will take more than 1 or 2 clock cycles, okay? And that is called as multi-phase clocking, right? To transfer, it will take more than 1 or 2 clock cycles. That is called as multi-phase clocking, okay? Right? So far clear about register transfer, right? And now this is another information which I have already said. If you want to move data from R1 to R4, what you have to do, we have to enable the R1 out and then you have to enable the R4 in, right? And that is the example we have already seen, okay? Right? And all this explanation I have already given, okay? Right? Now we will see about ALU operation, right? How the ALU will execute the operation, okay? You know that we will take a simple ALU operation, that is add operation, okay? That is add operation, right? That is considered as R1, R2 and R3. And R3, okay? That is we have to add the content of R1 and R2 and place it in R3, right? And before explaining this ALU operation, once again we will see the ALU connection so that you can be very clear with that, okay? So this is the, I'll explain it in a neat manner. You can see here, right? This is the ALU operation, correct? This is the ALU connection. As I said, it has two inputs. It has two inputs, right? One is directly obtained from the bus, that is B will be directly obtained from bus, and the other input you have to obtain from the multiplexer. The multiplexer will select either Y or it will select 4, right? And then it is given as an input as A, right? It will select either this one or this one, and that is given as an input to A, right? And then what ALU will do is ALU will perform that operation and it will store that operation in that particular temporary register, correct? Right, and that from temporary register it moved to the internal bus, right? And from here it can be moved to the content, okay? Now I explained very clearly here, right? Before going to that instructions, as I said, you have to understand R1, R2 and R3, correct? Right, that is you have to add the content of R1 and R2 and then move the content R3, right? Now listen very carefully, right? Consider this as R1. This is R1, and there is something here as R2, that R2, okay? And here as R3. If you understand this, you can write it by yourself, okay? The instructions can be, you can understand those instructions, program instructions very clearly, okay? So listen, that is what I have to do is I have to add the content of R1 and R2 and save it in R3, right? So, which means there is the content in R1, right? And there is a content in R2 already, right? All we have to do is we have to add R1 and R2, right? So, the very first step is, if this is R1, what I have to do, there is some content, right? What I have to do is I have to enable R out is equal to 1, right? If I select R out is equal to 1, that content will be moved to the internal bus, correct? That will be moved to the internal bus. Am I right? Right. So now from internal bus, what will happen here? Right. It has to go through this particular Y. So what will happen? We have to enable Y in. Y in will be enabled. So that the content of R1 will be moved to this particular Y. Right? Right. That is Y in is enabled, so it is moved to Y. Right? Now what multiplexer will do? Multiplexer will select Y because it can select 4 or select Y. Now it select Y, right? And once it select Y, the content of R1 will be given as an input to A. Clear with this? Clear with this? Okay, that is the content of R1 is moved to the internal bus, and then it is moved to the Y, and from Y it is given to the A as an input to the ALU through multiplexer, right? And parallelly, understand one thing very clearly. Parallelly, once the instruction from R1, right, from the data from the R1 is saved in the YN, right? Once it is sent to the YN, right, the R2 out will be enabled parallelly, right? R2 out will be enabled, right? So that what will happen? The R2 out will be enabled here, and it will be sent to this particular B directly. Right? Now you can see the R1 is present in A and R2 information is present in B. Right? And you know that ALU will have control signals, add, sub, and all those control signals. If add control signal is enabled, what it will do is it will add the content of R1 and R2. Correct? And it will be saved in ZIN. That is, ZIN will be enabled here. Right? ZIN will be enabled here. ZIN1 will be enabled here. So what will happen? The content of A will be saved in Z. As I said, Z will be a temporary register, right? So that will be saved in the Z. Okay. And from Z, what will happen? Z out is enabled. If Z out is enabled, what will happen? Z out is enabled. What will happen? If Z out is equal to 1, that content will be moved to the internal bus. Right? And once again, if R3 in is enabled, what will happen? The data in the internal bus will be moved to the R3. Right? Clear with this? Very simple. All you have to understand is, you have to understand the logic. Right? From R1, it reaches Y, and then through multiplexer, it reaches A. Similarly, parallelly, R2 reaches B. Right? And then it performs the additional operation, and then the temporary result is stored in Z. Right? And from Z, it is sent to the R3. That is what we need. Correct? Right? So that is the ALU operation. This is the very simple ALU operation. Right? And you can see here, this is what we have explained here. Right? If you want to move the content of R1, R2, what you have to do? First, you have to move the content of R1 to Y. Right? And then multiplexer will select Y, and it is given as A. And similarly, what you have to do, at the parallelly, R2 information will be sent to B, right? And then the ALU will perform the operation, correct? And then it will send to the Z, correct? And you can see this is the very clear instructions, right? That is, you can see here from R1, right? It is sent to YN. YN is enabled, and the R1 is sent, data is sent to the YN, right? And once it is sent to YN, what has to be done parallelly? R out has to be enabled, so that the R2 content will be in the internal bus, and it will be moved to the B, right? It will directly go to B, correct? And similarly, we got to select Y. Multiplexer has to select Y because that Y content will be moved to A, right? And R2 content will move to B, right? And then you have to enable add, right? So that it performs A plus B, that is the content of A plus B, and the result is stored in ZN. Right, and then the last step is you have to move the content of this Z to R3. Clear? Right? You can very clearly execute all these instructions. Right? If you understand the logic, you can clearly execute all this. You can clearly write all this information. Okay? Right. So today what we have seen is we have seen register transfer operation and as well as ALU operation of the processor. right? So all you gotta understand the logic, how the data flows from one register to the other register, what is the logic behind it, right? How the ALU gets the information, how it's executed, how it stores the information in the temporary register, and how it stores the other register. This is what you gotta understand, right? Hope you understand the logic. Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.